Hey class, if you've got this as one of your suggested videos from the Unit 8 quiz, then it means you missed a question that had to do with statistical significance and whether something is likely to happen by just chance or whether something is very unlikely to happen by chance. And with these, they'll give you some, probabilities and things like that. But the main thing with these is to just look at what is expected mathematically and then compare whatever they described happened with what is expected to happen. And if you're close to what was expected to happen, then you don't want to consider that unusual or or statistically significant. On the other hand, if something happens that's very, very unlikely with such a low probability and very different from your expectations, then you would want to say that that's statistically significant and there was a very low chance of that happening. It was very unlikely to happen, so therefore it is statistically significant. Some of this was in the Unit 7 homework assignment at the beginning if you needed to look over that. So here's just a sample of something similar to what you would see in those questions on the quiz. In an experiment testing a method of gender selection intended to increase the likelihood that a baby is a boy, it says 764 couples. Let me get a pen going here. 764 couples gave birth to this many boys. A company representative argues that this is evidence that the method is effective, meaning that it's successfully increasing the number of boys than we should normally see. Do you agree with this argument? Why or why not? So what you really ought to do is just take the total number of couples that had babies, knowing that the theoretical probability of having a boy is 0.5, similar to having a girl, 0.5. So you just take 0.5 or 1/2 of the 764 couples that had babies. So I'm just going to take a half of that by dividing by 2. And so 764 divided by 2 is 382. That is the mathematical expectation of how many boys we should see by just chance, by chance variation. So we then go see what they said happened. Well, there definitely is more boys that happened than 382, but relatively speaking, what happened is not really that much higher than what we would expect. In other words, it seems to be, well in line with just theoretical expectations, and it doesn't seem to be that any special gender selection method seems to be working. Now, so on that one, I would certainly want to say that no, I do not agree that this gender selection method is working because it's not really that unusual to see 391 boys out of 764. The 391, in other words, is very close to what we would have expected. Now, on the other hand, if you get a question that is similar to this, but instead of, so let's suppose it had said 764 couples gave birth, but then let's suppose it said that, say, 586 were boys. So out of 764, let's suppose 586 were boys. Well, we only expected 382 to be boys. That seems way above what we would have expected. And therefore, I would say that, yes, that would make it appear that the gender selection method is working because we're getting way more boys than we naturally would have expected from just chance variation. So it really just depends on finding the expectation and then comparing what happened to the expectation and deciding, does that seem really unlikely and far away from our expectation? Or does that seem close enough that I don't really think any special method is working? Another one, it may say something like, suppose you flip, say, 20 coins. And it could be coins that are 50-50 chance of getting heads or tails. It could be boy and girl babies that are 50-50. It could be anything where the two probabilities are equal. And that's not to say that everything. I mean, You know, a basketball player is not necessarily a 50-50 shooter, even though they either make or miss. Some people think that it's always 50-50. That's not the case. But certainly things like boy, girl, babies, flipping a coin would be examples of 50% chance for each of the two outcomes. So let's suppose you tossed a coin 20 times. And let's suppose you got heads on all 20 tosses. And in fact, I'm going to find the probability of that. So, or actually, let me do this. I want to erase that real quick. Okay. Let's suppose, okay, same thing, 20 coin tosses. But let's suppose it now talks about that if you tossed 20 coins all right in a row, then you actually have, let me figure this one out. Okay. In order for them all to be the same, like in other words, all heads, so like right in a row getting heads, 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 heads all the way until you get your 20th, or all tails, so tails, 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 all the way up through your 20th toss in a row. So the likelihood of that happening is actually 1 out of 524,288. Well, that's very unlikely to happen. If there's only one chance out of 524,288 for that to happen, that's very unlikely. So the question that you may have missed might have had something to do with this, where it says, okay, if you toss the coin 20 times and got all the same outcome on all 20 tosses, meaning either all heads or all tails, then you would want to put the response that implies that that would be very unlikely to happen. You know, if that happened, that would be statistically significant because that is very unlikely to get all 20 the same exact outcome. You know, usually at some point you're going to see, you know, if you've been getting a bunch of heads in a row, usually you're bound to see a tail come in there. So it's just, I think on one of them, it's going to give you that actual probability, and you would have to realize that, okay, that's very unlikely to get all 20 or whatever number they give you to be the same outcome. And when they give you that kind of probability, you realize that, yes, that would be statistically significant because that's so unlikely to occur. That's such a small chance of happening. So like I said, if you got this video, it's something to do with either that, with the coin tosses, although it could be like boy and girl babies, same concept, or these where you had to think mathematical expectation and then compare what they're saying to that to be able to tell what the correct answer is.